Now in the next section, 7 through 12, you're doing the exact same thing. The only difference is that they're telling you that these are now regular polygons. Remember, the term regular means that all the sides are congruent, and more importantly to us, all the angles are congruent. So we're going to do the same thing, but now they're asking us to find the measure of each angle. Not all the angles together, but each angle. So you're still going to use that triangulation formula, but then what you're going to do after you find what all the angles are added up to together, divide by how many angles there are. And that'll give you just the measure of one angle. Remember, because they're all the same with the shapes being regular, whatever one of the angles is, all of the angles have to be. So let's start with the easy one, the one we already know. Number 8 sure looks like a square. And if it's a square, which it would have to be because they've already told us the shape is regular, we know that all the angles would be 90 degrees. So let's work it out and make it happen. Use the triangulation formula. N minus 2 times 180. This has 4 sides, so I'm going to do 4 minus 2, which is 2, and then multiply by 180, which is 360. And again, that's exactly what we did on the previous 6 questions. But now you're finding just the measure of one angle. So you're going to divide by how many angles there are. Well, there are 1, 2, 3, 4 angles here. So I'm going to divide by 4, and lo and behold, exactly what we thought would happen happened. We got 90 degrees. That's a good indicator that we're also doing what we're supposed to be doing correctly here. So let's go back now that we know we're doing it right and go try this on 7, and then we'll go try this on question 9. Number 7 has 1, 2, 3, 4, 5, 6 sides. It's a hexagon. So I'm going to take the 6 sides and subtract 2, which is 4, and then multiply by 180, which is 720. Again, what makes this different from the previous section now is you divide by how many angles there are. Well, there are 1, 2, 3, 4, 5, 6 angles in this shape. So I'm going to take 720 and divide by 6. And when I take 720 and divide by 6, what's generated is 120. So each angle has to be 120 degrees. And indeed, these angles do kind of look like they'd be about 120 degrees. They're definitely bigger than 90. They're way less than 180, a straight line. They would be about in that ballpark of 120 degrees. If we got something that was like this, and we said 120 degrees, we would know something is wrong because that's an acute angle. An acute angle has to be between that 0 and 90 marker, but if we had an answer of 120, that wouldn't make any sense. So now question 9, the stop sign, the octagon, which has 8 sides. So 8 minus 2, which is 6, and then I'm going to take 6 and multiply by 180. 6 times 180 in this case is going to generate 1080 degrees. Now divide by how many angles you have. Well, you have 1, 2, 3, 4, 5, 6, 7, 8 angles. So I'm going to divide by 8. Have you noticed something here? There's one other thing I want you to see here. Notice that the number of sides and the number of angles are exactly the same in these shapes. That's an important factor that could save you some time down the line here. So when I take my 1080 and divide by 8, I get 135 degrees. So each angle in here measures 135 degrees. Let's wrap this up by looking at the 3 questions at the bottom there. They're asking us to give all the names that apply to each figure. So what you want to do here is look at that quadrilateral image map and figure out what the top level is that fits the shape and then follow it down and see if there's others. Or go the other way. Start at the bottom, find the lowest thing that matches the shape, and then work your way back up. Now notice that all of these are 4-sided figures. So the term quadrilateral applies to all of them because they're all 4-sided figures. Now the main chunk of the quadrilateral image map is various types of parallelograms. Parallelograms have opposite sides, congruent, and parallel. So this shape right here that you see at number 13 does indeed have that. This side and this side are parallel, look to be the same length. This side and this side are parallel and to have the same length. So that would indeed be a parallelogram. The other two do not have that feature. So we can't say parallelogram for anything else. Now, we can follow down the map for this question for parallelogram, and the next thing there would then be square perhaps, but we don't see any right angles, or rectangle perhaps, but we don't see any right angles, or maybe rhombus. Rhombus, remember, is kind of like a square, but it's tilted. All right, the angles would all be the same, and the side lengths would be the same, or rather the opposite angles would be the same, and the sides would all be the same, all four. So here we would have to be able to show that this and this are the same, and this are the same, and boy, they sure do look it. If we cut a line down the middle and folded this over, we would absolutely see that those match up, and the same going this way. So this one is also a rhombus, and that's really all you can do with that one. Now I'll leave you the easy question, number 14, but let's go over and look at 15, because 15 is a little bit different. 15 only has one set of parallel sides. So even though it's a quadrilateral, we won't be able to flow down the parallelogram side there. One set of parallel sides makes a trapezoid. Now really, there's only one other place you can go from trapezoid when you look at that map, and that's isosceles trapezoid. Now we know the word isosceles. Isosceles means that two sides are congruent. So if we have two sides there that are congruent, we can also call this an isosceles trapezoid. Otherwise, that's it. Well, looking at the side on the left and the right, they sure do look the same because they are. So this is also an isosceles trapezoid. The trapezoid that's not isosceles is usually very easy to spot because the two sides don't even look anything close to each other. For instance, what I'm drawing up there right now would be a trapezoid, but it's very easy to tell that this and this do not have the same length. It's going to be very easy to spot when it's isosceles because they're going to look the same, whereas here they don't even come close. So yes, trapezoid for what I drew, but not isosceles. But for number 15 that's on the board, absolutely an isosceles trapezoid. Two sides congruent, the left and the right.